The overall goal of this procedure is to create an optimized supercontinuum in the mid-infrared through tapering a chalcogenide fiber. This is accomplished by first constructing the fiber tapering setup. Which allows for spectral monitoring to determine the level of broadening during the tapering of a chalcogenide fiber. The second step is to prepare a short arsenic trisulfide fiber to be tapered. Next, the optical fiber is inserted into the tapering setup with the pump source coupled to the fundamental mode of the fiber. The final step is to heat the fiber and begin the tapering process, terminating the tapering when the spectral measurement is maximized. Ultimately, a coherent and instantaneously broadband supercontinuum in the mid-infrared will be generated after passing through the in-situ tapered fiber.
The main advantage of this technique over existing methods, where tapering to a set fiber diameter is determined by simulations, is that an optimally broadened spectrum can be obtained in a single fiber taper experiment.
We first had the idea for this method when we realized that efficient supercontinuum generation in a tapered chalcogenide fiber could be adversely affected by the imperfect reproducibility of the tapering process. So we thought we could experimentally optimize the supercontinuum generation by observing the spectrum during the tapering process.
To build the tapering setup, secure two motorized linear stages approximately in the center of a 12-inch by 12-inch breadboard. The stages should be in contact and oriented to translate towards and away from one another.